Hi everybody, welcome to another video in Pre-Calculus section 7.2, the law of sines. The next two sections we will solve triangles, general triangle. So to solve an oblique triangle, mean to find the length of the sides and the measurements of the angles. By oblique, we mean not a right triangle. Meaning that none of the angles is 90 degrees. Of course, if it is 90 degrees, then we have the right triangle. Of course, the trigonometry would be pretty simple from there. Right. So, first, once again, in the triangle, opposite to angle A is sine A, opposite to angle B is sine B, and opposite to angle C is sine C. Right. Again, there are three sides and there are three angles. So, we need to have three to find the other three. Once again, we need to have three information to find the missing three information. But one of those information has to be a side. We cannot have three angles, because if we have three angles, that's kind of redundant. We only need two angles. The last one can be subtracted from 180. So having two angles, having all the angle is not enough. So we need to have three information, and one of them is a side. If that is the case, then we can find the solution. Right, that can classify in these scenarios. So case number one, where we have two angles and one side. Could be any side, but two angles and a side. So we have A side, meaning angle, side, angle, side, angle, angle. So angle, a side, and angle, or side, angle, angle. Right. Next, two sides and the angle opposite of one of them. So these scenarios where we have two sides, we have two sides and we know this angle. We don't know that. Right. So watch out for these scenarios. First of all, don't say that backward. So the side, and the angle. And this special case, we have two sides, one angle, but that angle is not in between the two sides. That angle is not in between. So this is special case that we have to watch out for. The other case, we have a unique solution. Once again, the case where we have two sides, but the angle is not in between. If we have this angle, then that is the side, angle, side. This one has a unique solution. This one may not have a unique solution. So watch out for this scenario where we have two sides and the angle is not in between. This we may have no solution, one solution, or two solutions. Right. So in this section, we will use the law of sines. So the law of sines saying that for any triangle with the sine A, little b, little c, and opposite angles respectively, A, B, C, sine of A over A, sine B over B, and sine C over C. Of course, when we say sine of A, we mean sine of angle A. And if we say A by itself, that is the sine A. So A, B, and C. Opposite to angle A is sine A, opposite to angle B is sine B, opposite to angle C is sine little c. Then why do I have a raw circle? Well, this special circle is called the Circum Circle, the circle that go around all the vertices of a triangle. And that is the circumcenter. Now, the special is that the radius of this circle is R. And it can be shown that this is equal to 1 over 2R. But of course, we don't really need to focus on that. Just sine of A over sine A, sine of B over sine B, and sine of C over sine C. It is equal to constant. Right, so we're going to use like that fact, that theorem. Now, the other useful fact about triangle, all the angles add up to 180 degrees. We already know that. And this will come in handy as well. The longer side face the bigger angle. Right. So let's look at these examples. So, show the triangle with the given information. Right. Even though we have the graph, but I highly recommend that you will write a summary like this. So in this case we have angle A is 45 degrees, angle B is 55 degrees, and angle C we don't know. The sine C we don't know, sine B we don't know. This is the sine A. Right. So I write now what we have and what we need to find. So angle A is 45 degrees. Sine A is 5. Angle B is 55 degrees. And we do not know C, so we do not know angle C, we do not know sine B, and we do not know sine C. So now we just find the missing information. Right, the first thing, the easiest one is angle A plus B plus C, all the angle add up to 180 degrees. So to find C, we subtract from 180. So that's the first thing we do. Angle C is 180 degrees, subtract 45, subtract 55. That gives us 80 degrees, right? Once again, if we solve triangles, make sure that it is in degree mode. 180 minus 45 minus 55. Right, 80 degrees. And so we find that is 80 degrees. Right, next. Of course, we have the law of sine, so this is the title of the section, so think in context, that's what we use, right? But before we do that, let's write this important note. This will compare to the next section. So the law of sine, we use the law of sine where we have a pair of opposite angle and sine. So use law of sine. If we know a pair of opposite angle and sine. Right. So use the law of sines if we know a pair of opposite angle and sine. So just like what we have here, we have a pair of opposite angle and sine. When we see this, that is the law of sine. Right, so I will write out the law of sine. Sine A, we do know is 45 degrees over sine A. Sine of B over B, we don't know. Sine of C 80 degrees over little c. By the way, we do know A is 5. Right, so just law of sine. So sine of an angle divided by the opposite side is a constant. So we have 3 such ratios. Right, now it's easy. We just take this 2 ratio, cross multiply to solve for B. So B times 70. Cross multiply B sine of 45 degrees equal to 5 times sine of 55 degrees. So B equal to 5 sine of 55 degrees divided by sine of 45 degrees. So 5, by the way, it is in degree mode. Yeah. 5 times sine of 55 divided by sine of 45. And yeah, so 5.79. Yeah, just keep 1 decimal places. 1 decimal place, 5.8. Right. That's the first ratio. Give us that. Now, we need to find C. Well, in this case, we cannot really pick and choose. Even though we've solved for angle C 80 degree, it is not what is given, but we have no choice. We have to use it. So, and taking those 2 ratios, cross multiply, we have C sine of 45 degrees equal to 5 sine of 80 degrees. So to solve for C, 5 sine of 80 degrees over sine of 45 degrees. Five sine of 80 degrees divided by sine of 45 degrees. I have 6.96. So it will be one decimal places, so like more 7.0. Right, now let's put the answer here. B is 5.8 and C is about 7.6. I mean 7.0. Now, the final check I want to mention is that we did have a fact that a bigger angle will face the longer side. So in this case, the biggest angle we have the longest side, which is good. The smallest angle, the shortest side, which is good. So it would be nice if we check that and make sure that it is the case. Bigger angle face bigger angle face longer side. Right. So of course we can draw the triangle, which I always recommend we do that. So it's not that we draw the angle with the exact measure, but what we do, of course, just get the idea. What we are given, what we need to find. Angle A 20 degrees, angle B 25 degrees. Of course the measure is way off. And sine C, which is opposite to angle C. So in this case we have angle, sine, angle. As the previous one we have angle, angle, and then a sine. Either case has unique solution. Right. So now let's write a summary. Right, so what do we have? Angle A, 20 degrees. We do not know A. Angle B, 25 degrees. We don't know B. Angle C, we do not know angle C, but we do know sine C is 5. Right, so that's what we have. But similar to what we have on the previous problem, where we know two angles, we know the last one, because they add up to 180 degrees. So we just take 180 minus 20, and minus 25. So that is 135 degrees. It's just right here. Angle C, 180 degree, minus A minus B, and that gives us 135 degrees. Right, that's good. That's good. Now what we have next is a pair of opposite sine and angle, because that screams law of sine. Right, we'll just write sine A over A, sine of A, 20 degrees, over A, don't know. Sine of B, 25 degrees, don't know sine B. And then sine of 135 degree over sine C, we do know is 5. Of course, the reason we need to have a pair of opposite sine angles so that we will know a ratio, and then we just find the missing information on the other ratio. Right. Now, let's group the first one and the last one, and then cross multiply. We have 5 sine of 20 degrees equal to A sine of 135 degrees. Right? Cross multiply. And then do solve for A. We have 5 sine of 20 degrees divided by sine of 135 degrees. So we could enter fraction if we want to. Make sure this in degree mode is the most important. Right. 5 sine of 20 divided by sine of 135. And we have 2.418. Again, I only write 1 decimal places. Of course, in the homework or test, make sure you read the problem and use, the right answer in the correct decimal places. This is 2.4. So that's what we have. Now, the other ratio, take the last two and then cross multiply. 5 sine of 25 degrees equal to B sine of 135 degrees. To solve for B, we have 5 sine of 25 degree divided by sine of 135 degrees. Five sine of 25 divided by sine of 135 is 2.98. Of course, if we round that to 1 decimal places, this is 3.0. Right, the final check. Biggest angle, longest sine, that's good. Smallest angle, shortest sine, that check. Right, so in this scenario, when we are given two angles, and one side, regardless of the orientation, we have a unique solution. Right. Now go to the sine angle, this special case. Right. This sine angle, we might have one solution, two solution, or no solution. Right. So now, in this case, what we are given is a sine, another sine. Sorry, didn't read. So we have a sine B, sine A, and angle A. Right. The problem here is this side is too short. It will not enough to touch this side to form a triangle. In this case, that could be no solution. Now, if it is just long enough, it will have one solution. Or if it is too long, it will touch on the outside, and it has one solution. Now, the special case where we could have two solutions is this, where the length A is just enough, so we have one triangle here, right? Angle, sine and sine, one solution, and the big triangle is the other solution. Again, sine, and that angle. So watch out for this scenario when we have a sine, and angle, and the characteristic of that is no two sine, and the angle in the middle, and the angle is not in the middle. It's not included. By included, I mean in the middle. It's not in the middle. Let's just spell it out. And this is called the case of sine, and angle. Right. When we have these scenarios, have to be careful because we may have one solution, two solution, or no solution. You will see. Right. Let's look at this first example. Of course, if we are not given the graph, look at the number. We might not be able to see it, but let's just write out the summary. Right. We know sine A is 2. Do not know angle A. Don't know anything about B. We do know angle C is 50 degrees. And sine little c we don't know. Actually, we do know it's 1. Right. So that's what we are given. And of course, regardless, remember the previous scenario where we have a pair of opposite sine angle. That is the law of sine. But also, if we draw it out, in this case, we have sine A opposite to A. We have sine C opposite to C, and the angle C is not in between those two sides. So this is this is the sine angle. Almost spelled that backward. Right. So, of course, when we have that, have to be very careful. But regardless, we have a pair of opposite angle and sine. So that is law of sine. Right. Try that out. Sine of angle A, which we don't know, over 2, equal to sine of angle B, don't know that, over sine B, don't know that either. Sine of angle C, that's 50 degrees, and over sine C, which is 1. Right. Of course, sine B and B we don't know, so we're not going to be able to use anything related to that. Right? So we just have to go with this. Cross multiply. We have sine A equal to 2 sine of 50 degrees. Of course, 2 sine of 50 degrees. Two sine of 50 degrees. It is still in degree mode. Yep. So this 1.5232. And sine A equal to that. Of course, if you notice, sine of an angle cannot be more than 1, cannot be less than -1. So there's no solution here. But let's assume that we don't know that. When we do this, we'll have A equal to sine inverse, whatever that is. Typically that will be plus 2 pi n, but because this is in the triangle, we don't have to do that. Just whatever it is, just going to keep it. But we might have, like I said, we're not going to write plus 2n pi because it is just in the measure of a triangle, of an angle in a triangle. So it will not be more than 360 degrees for sure, not even more than 180 degrees. Right, so either that, remember sine is either the sine inverse, or we could have the supplement. So either that or that, either the sine inverse or 180 degree minus the sine inverse. Right, they'll say why we didn't use that before. Well, we didn't, because in here we know two angles, we know the last one, we don't need to do the sine inverse. We don't have to solve for this equation, sine of something equal to a number. When we solve for that, sine inverse or supplement of the sine inverse. But either case, it is undefined. Because if we're not sure, we have that number, just do sine inverse. Give you an error, right? It is not in the domain. So undefined, therefore we have no solution. In this case, there will be no triangle. Right. Next, we have this scenarios. Right, let's write a summary. We know sine A is 4, sine B is 3, and angle A is 60 degrees. Do not know angle B, do not know angle C, and do not know sine C. Right. So note that in this case, once again we have a pair of opposite angle and sine. So this definitely law of sine from. But to make sure that what we have here is we know sine A is 4, sine B opposite to B is 3, and the angle A here is not in between the two sine. So once again, this is the sine angle scenario, in which case we might have no solution, one solution or two solutions. But regardless, where we start, we look at this, and that is the law of sine. Every time we have a pair of opposite angle and sine, that is the law of sine. So I will write sine of 60 degrees over A, we know is 4. Sine of angle B, we don't know that. Divide by sine B is 3. Sine of angle C over sine C, we don't know that, so this ratio is useless. Just use this ratio, these two ratio. Cross multiply, and so for sine of B, first cross multiply 3 sine of 60 degrees equal to 4 sine B. So sine B equal to 3 sine of 60 degrees over 4. 3 sine of 60 degree. Yeah, still in degree. Right, divide by 4. Right, so we have that. 6,495. That. Even though we write just a few decimal places, but in the calculation, I always use the whole number. Right. So once again, to get back to the angle, there will be the sine inverse or the supplement to that. So B equal to sine inverse of this. Or we might have the supplement Right, so we have sine inverse of that 40.5 degrees. Or we might have B equal to 180 minus that. Uh, 180 minus that. 139.5 degrees. So we have two scenarios. One of them is B equal to 40.5 degrees, and the other one is 139.5 degrees. Actually, I will quickly draw the other scenarios here. And we still don't know B, don't know C, and little sine C. Right. The first scenario we have is 40.5 degrees, and the other cases we have 139.5. Right. Now these scenarios we don't have to go any further because the angle add up to 60 plus 139, that is more than 180 degrees. So this is no solution from here, right? Once again, this solution doesn't work because the angle add up more than 180 degrees already. There's no room for C. That's one reason, right? That is good enough reason. The other reason is bigger angle face a longer side. So whatever we have here, this angle, this solution have to be less than 60 degrees, cannot be more than that, right? Because simply bigger angle face the longer side, we have the shorter side here, we should have smaller angle. So in this case, we have, this is not a solution. Not a solution here. Because like I said, one of them is enough. In this case, A plus B plus C is more than 180 degrees. So it's not a triangle. And also, angle A bigger than, I mean sine A is longer than sine B, then angle A must be bigger than angle B, right? So this is not because of that. Either that or we say bigger angle does not face longer side. So we do not continue from here. We will take the 40.5 and we go from there. That's what we have. Right, next, like I said, usually in the right triangle we can pick and choose the information, whatever given, and we go from there. However, in these scenarios where we have just any triangle, we cannot choose anymore. Whatever information, we just have to go from there. Now we know A and B, we should know C. So first, A plus B plus C is 180 degrees. So angle C is 180 minus A and minus B. So 180 minus 60 and minus angle B 40.5. Right, so we have 79.5 degrees. Right, the rest is easy. We put in the ratio here for the law of sine. Yeah, so we're done with the first, we will keep the first ratio. We got B already. Now we go to sine of C, which is sine of 79.5. We do know the angle now. We just don't know the sine C. So it's easy now. Cross multiply and solve for it. So cross multiply C sine of 60 degrees equal to 4 sine of 79.5 degrees. So, and so for C, sine of 79.5 divided by sine of 60 degrees. For sine of 79, I should use this number divided by sine of 60 degrees. 4.54, what is 4.5? So once again, biggest angle, longest sine, which is good. Smallest angle, shortest sine. That's good. Right. Now let's look at these scenarios. This says 2 solutions, right? So that's why I'm not going to even draw in the triangle here. Just draw a summary. Right. Angle A is 40 degrees. Little a is 7. Angle B is, don't know angle B, don't know angle C, and don't know sine C. But we do know sine B is 9. So in terms of what scenario we have here, just a triangle A, B, and C. So what we are given, angle A, sine A is this one. And sine B is this one. So once again, this sine, that sine, and the angle not in between. So 2 sides and the angle not in between them. So I have to be careful in these scenarios. Regardless, we have a pair of opposite sine angle. So this is law of sine. Right. So we write out the ratio. Sine of 40 degrees over 7 equal to sine of B, which we don't know, and sine B is 9. We do know that. C, we do not know anything about angle C or sine C. Right, simple enough, right? Now, of course, this ratio is useless because we don't know either of them. Let's go from here. Cross multiply and solve for B, right? So 9 sine of 40 degrees equal to 7 sine of B. So we can solve for sine B. Sine B will be equal to what? 9 sine of 40 degrees divided by 7. 9 sine of 40 degrees divided by 7. It is in degree mode. Yep. So 0.826. Right. If we want to get to the angle, there will be 2 solutions. Either B equal to sine inverse of 0.826, or the supplement to that. Right, so we do that. What is sine inverse of this? It is still in degree mode, and we have 55.73, 55.7. Yeah, as you see, even though I only write 1 decimal places, but when I do the calculation, I use the whole number in the calculator. Calculator on that side. Or we could have B equal to 180 minus that. .3 degrees. So we have 2 answers. Let's put that in the scenario and see if it works. So A is still 40 degree, little a is 7, B, actually we solve now is 124.3. We know B is 9, don't know angle C, don't know sine C. Right, 50 now, just put this in 55.7 degree. Now let's stop and think about this for a moment. This one, 40 and 55.7, there is certainly room for angle C, so that's good. Furthermore, bigger angle, longer sine, shorter, smaller angle, shorter sine. So same thing here, 40 and 124.3, there is room for angle C here, right? So that's good. And also bigger angle, longer sine, smaller angle, shorter sine. So that's good. So look like both of them will work. Right. Now we have two scenarios, and now we just need to work on both of those scenarios. Right. Now we have B, we have A. Now to get C, of course, A plus B plus C is 180 degrees. So to solve for angle C, 180 minus A minus B. So we do that, 180 minus 40 and minus angle B. Right, 84.3. Now we just need to find sine C. To find sine C, we can put it back in this ratio. Sine of 40 degrees over 7 equal to sine of angle C. Now we know it's 84.3 degrees over little c. Of course, cross multiply, and we should be able to solve for C. Right. So C sine of 40 degrees equal to 7 sine of 84.3 degrees. So 7 sine of 84.3 degrees over sine of 40 degrees. Right. So 7 sine of 84.3. Once again, I'm not going to use 84.3. I use the whole bunch of decimal places. Divide by sine of 40 degrees. We have 10.8. Yeah, 10.8. So, final check. Angle add up to 180. Yes. Biggest angle, longest sine. Smallest angle, shortest sine. So this is check. So this is one solution. Now we go to the second scenarios. Once again, they add up to 180 degrees. To get angle C, subtract from 180. And 124.3. 180 minus 40 minus 124.3. So this one. 180 minus 40 minus that number. Right, 15.7 degrees. Now we just need angle C. We use the same ratio, sine of 40 degrees over 7 equal to sine of angle C sine C, we do not know. Again, cross multiply and solve for it. So C equal to 7 sine of 15.7 degrees over sine of 40 degrees. So 7 sine of 15.7, I will take the whole number divided by sine of 40 degrees. So I have 2.95. Yeah. So final check. Biggest angle, longest sine, smallest angle, shortest sine. So that check. Right. Once again, even though when we write the answer, we write the rounding numbers, but when we do the calculation, I'll take the whole number in the calculator. Sorry, the recording software crashed in the middle, so I have to record the last part again. Right, so I have this application problem. To measure the height of the mountain, a surveyor takes 2 signs at the peak at a distance 900 meters apart. So at first, he stand here and look to the peak of the mountain, and the angle is 47 degrees. And then he step back 900 meters, look to the top of the mountain again. This time the angle is 35 degrees. Right, that's what it is. If the transit is 2 meter height, what is the height of the mountain? Right. So before we do anything, let's just put the number so we can refer to. So this is angle A. This will be angle B. And just for the simplicity, I will not write this B. Let that be something else. I prefer the opposite to angle B is the sine B for this triangle. And then this is angle C. Opposite to that is sine C. Right. Let this be D. Right. So on the big scheme of things, let's try to find as much information as we can with this. 47 degrees. So the angle C here supplement to that because this forms a straight angle, so we can find angle C. So when we draw this, obviously we see 3 triangles here, right? This triangle, the right triangle, and the bigger right triangle. So there are 3 of them. But we focus on this triangle first, and then the other 2 right triangle later. Now, this angle C plus 47 degrees is 180 degrees. So we start with that. C plus 47 degrees is 180. So C equal 180 minus that. Right. Make sure it is in degree mode. So it's good. 180 minus 47. 133 degrees. So that is the angle C here, 133 degrees. Right. With that we can find angle A, right? A plus B plus C is 180 degree. So angle A 180 minus angle C minus B. $35 minus 133. 180 minus that minus 35 is 12 degrees. Right, so we have all the angles in this triangle here. So what do we find here? Of course, if we know all the angles, then we need to find one of the sine, right? So what actually we'll do is we're going to find sine B first, and then when sine B, then we can go to the right triangle and we can find D after that. So find B, then find D, and then at the end the transit is 2 meter height, so we have to find D plus 2 meter will give us the height of the mountain. Right, so first we'll find B. Right. In this triangle though, we have angle A and the sine A. So that of course is the law of sine. So for triangle ABC, I use the law of sine. Sine of angle A, which is 12 degrees, over the length of sine A, which is 900, equal to sine of B, 35 degrees, over B, the sine B we don't know. Okay, cross multiply and solve for it. Right, and then divide by sine of 12 degrees. Right, that gives us 2,482 meters. Right, so we have that. So we have B. Now we can focus on triangle ACD. I should use just spell it out. And this is the right triangle ACD. The D is the right angle. Yeah, D is equal to 90 degrees. Alright, what do we have? Right, we only have the angle here is 47 degrees. And with respect to 47 degrees, D is going to be opposite. And B is the hypotenuse. And opposite hypotenuse, that has to be sine. Of 47 degrees equal to opposite, which is D, over hypotenuse is B. So we have D equal to B sine of 47 degrees. Right, all I do is, that is B in the calculator times sine of 47 degrees. Give us 18 15.9 meter, and that is the height. D plus 2 meter, the height of the transit, give us the height of the mountain. So we have that plus 2, 18, 17.9 meter. Right. So this one we have more than one triangle to consider. One is the obtuse triangle, one is the right triangle. Right. So the reason that we cannot find the height of the mountain because it is the mountain. We cannot walk to the point where directly below the peak of the mountain, usually. So in that case, we cannot walk to the bottom, so we can find that height just using the right triangle. We cannot do that. So in that case, we have to use a related triangle to solve for it. Right, so that's what we have from that problem. Right, now another application problem. So a Coast Guard station, Zulu. So Zulu is on the west station, X-ray. A ship at sea send an SOS signal to both of them. From Zulu, it is 50 degrees east of north. And from X-ray station, from the station X-ray, the bearing is 60 degrees west of north. So let me draw this here. Right, I say this is the coastline. Right, Zulu here, and X-ray there. Right, draw the north line, the north-south line. Right. The first one, from the Zulu station, it is 50 degrees east of north. So this is the bearing, 50 degrees east of north. And then from the X-ray, from station X-ray, it is 60 degrees west of north. Actually, this is 60 degrees. This is a half equilateral triangle. So I can just say 60 degrees here. Exactly 60 degrees. Right. And this is 60 degrees west of north. North. And then on the west side. Right, so Z, X, let the shape be S. Right, now we have, of course, then we have the triangle S, X, and Z. That's alphabetical order like that. Right, now this is 90 degree angle from north and east side. So 90 degrees. So this subtract from 90 degree. Subtract 90 minus 50 is 40 degrees, and 90 minus 60 is 30 degrees. So we have that. Of course, if this is 40, this is 30, we can find S easily. But now let's just draw the triangle and summary what we have. Summarize what we have. Right. We don't know angle S. But we do know that the distance between the station is 100 miles. In alphabetical order, we know angle X, 30 degrees. Do not know X. We know angle Z, 40 degrees. And we do not know Z. Right? So, first, when we know two angles, we surely know the last one too, because we just subtract from 180. So that is 110 degrees. Right. Now, just like when we solve the right solving triangle, when we have a pair of opposite sine angle, this is a law of sine. So sine of 110 degrees over 100 equal to sine of 30 degrees over x, which we don't know, or sine of 40 degrees over z, that we don't know. Right, so we take this. By the way, what is the question? How far is each station from the shift? So pretty much we asked to find x, and we asked to find z. Right. Cross multiplying here, x times sine of 110 degrees equal to 100 sine of 30 degrees. So x equal to 100 times sine of 30 degrees over sine of 110 degrees. And 53.2. Of course, the unit should be miles. Right, and then we can do the same thing to find z. Just take the first ratio and the last ratio. Cross multiply z of sine of 110 equal to 100 sine of 40 so we have z equal to 100 sine of 40 degrees over sine of 110. So pretty much the same thing here, except I only need to change the 30 degrees to 40 degrees. I have 68.4. Right, so from the Zulu it is from Zulu that distance x, which is 53.2 mile, And from X-ray, it is the Z, which is 68.4. Before we do anything, of course, the bigger angle will face the longer side, so this will be longer distance than this one. Right. The next part of the question: if a helicopter capable of flying 200 miles per hour is dispatched from one of those two, the shorter one, of course, in that case, that would be Zulu. Zulu is closer to the ship than X-ray. How long will it take to reach the ship? So this is easy. We have 200 miles per hour. So this is the speed. And we have speed is equal to distance divided by time. So we have time is equal to distance divided by speed. Distance, the shorter distance of the two is from Zulu is 53.2 miles. The speed is 200 miles per hour. So divide them. We have 53.2 divided by 200. So at the time is equal to 0.266 unit would be hour. Now, if we put on 1 hour, 1 hour is 60 minutes. Cancel out that. So we multiply that by 60, and we have 15.96. So let's round up to 16 minutes. So in this problem, Zulu is the closest station to the ship. If it dispatch a helicopter, it will take 16 minutes to reach the ship. Right, so that's what we have for this problem, and that's what all I want to cover in this section. As always, thank you for watching, and see you in another video in Calculus.